Good evening, everyone. I'm Ryan Kruger, and I'm going to run you through my final project. So, what is a stable stamping process? That's the question that we're hoping to answer in this project. First, I want to explain what stamping is. So, stamping is a process of forming sheet metal into parts. And for simplicity's sake, there are two major components to the stamping industry. Number one is the die. This right here would be the die. And the second is the press. This piece of equipment here is the press. Now, dies and presses come in all different shapes and sizes. They can be everywhere from braces. In high school, I job shadowed a die maker who made dies for braces that go on your teeth, all the way up into full automotive body sides. So they come in all different shapes and sizes. There's a process, there's a draw process, trim, pierce, flange. All those go into what is required to making a part. So the overview of this project is a stamping plant wanted to check the process variability of their stamping process. They made 3 runs and they measured the parts from all 3 runs based on random acceptance testing principles. What they discovered is run A, when they put this on the control chart, run A looked really good. Here's your upper limit, your lower limit, your median. Same with run B, same with run C. However, when we plotted those as a whole across the 3 runs, we can see that run A was tickling the lower control limit here, B was out of range, and C was just below median. So what we'd want to do is we really kind of want to hone in on what was going on here with run C. So the first thing we did, we started as a Ichikawa diagram, also known as a fishbone diagram. We looked at what could be causing it from the measurement, machine, people, material, environment, and management standpoint. And the 2 that we identified as most probable root causes are press parameters and gauge repeatability. So the first thing we want to do was eliminate the gauge. So we conducted a gauge repeatability and reliability study. And this is an actual study from one of the gauges that my team makes. We have 8 data points. We measure 10 parts. Actually, we measure 1 part 10 times. This eliminates the possibility of the part being the source of variability. So we take the part off, put it back on 10 times. And here you can see our range. And in order to be acceptable, the delta from the 10 runs must be less than 10%. That's an acceptable range. 10 to 30% is marginal. So in this case, you can see we had 3 runs that were acceptable and 5 marginal, which in the end is absolutely acceptable. The next thing we want to do is we want to do a design of experiments and plot some of the other possible variances coming from the press parameters. Now this chart here is actually a hypothetical chart because I don't have real data, but what does it do would tell us what our tall pole was or what process parameter we should hone in on. So with that, I've actually constructed a process parameter sheet here with some of the variables in the stamping press. So you got your nitrogen, what's your nitrogen pressure through workstation 1, 2, 3, 4, 5, what's your shut height, what's your SPM, and what's your cushion tonnage, and what's your loop settings. Now in a real example, we would plug these into that DOE and it would tell us which one of these we need to hone in on. So in conclusion, we recognize that variation was not realized within the run, but was actually realized from run to run, telling us that something varies every time we set that die. We've eliminated gauging as being the root cause, and then we've conducted a design experiment chart which would identify which one of those process parameters would be the most likely contributor to our problem. And then for the solution, we implemented the process parameter sheet, which would be how we control our process when we set it from run to run. We'd want to replicate the same parameters that were on run C and make sure they are consistent every single time we press go on the die or on the press.